So this is 3.3b. We're still on the first derivative test. So we're going to find relative extremas. And so what do we need to get to? A what? A derivative. We need to get to a derivative. However, we have x to the fourth plus 1 over x squared. I don't want to use the quotient rule. What could I do?
You could just put it in the numerator and put it negative.
Okay. I could distribute dividing. That's where I want to go. All right. We could actually say x to the negative second up here. That's what we could do, which technically we are. When we distribute dividing, what could it manipulate to?
X squared.
X squared and then plus what? 1 over x squared. How do I actually want to think of that as? X to the negative second. All right. And so now when we're taking our derivative, my derivative of x squared is what? 2x. And then I have the derivative of 1 over x squared, but I really want to think of this as x to the negative second. And so then I bring down the negative 2, and then I subtract a power. So now I have minus 2x to the negative third. And then I can factor out a least power. That's going to make my life a little bit easier. So what could we factor out? A 2 and then a what? An x to the negative third, exactly. And so then if I factor out an x to the negative third from an x, that's really an x to the what power? Fourth power, because we subtract them. Because now I have a 1 minus a negative 3, so now I have an x to the fourth. And then if I take out the same thing, it's still minus 1. And so now when I rewrite my derivative, I would have 2 staying up top. And then I have x to the fourth minus 1 over x cubed. And so there's my simplification of my derivative. So now we're going to find our critical numbers by taking our derivative and setting it equal to what? 0. And so when does my derivative equal 0? At x equals what? 1 and negative 1. That's when my derivative is equal to 0. But there's also a problem. Where's my problem at? It breaks at 0. It's not even a domain, or it's not even my derivative breaks. It's actually my function. My function breaks at 0, so it's really a domain issue. It is not actually a critical number. It's a domain issue.
Why does it break at 0?
Because I'd get a number over 0. What is that when I get a number over 0? It's a vertical asymptote. So my derivative doesn't exist at 0. Because it's not even defined at 0. It's a domain issue. All right. So now we're going to make our number line with our domain issues as well as our critical numbers. And so now we'd have negative 1, we get 0 and 1. So when we back substitute something in on our interval, we substitute it back into our what? Our derivative. So what can we pick left of negative 1? Negative 2. So now when I substitute in negative 2, this one's going to be negative 2 to the fourth power. Is it going to be more or less than 1? It's more. And so now we have a positive over a what? A negative, which makes a negative. And then let's pick something between negative 1 and 0. Negative 0.5. I love that. So negative 1/2 to the power of 4. Is that going to be more or less than 1? It's less than, it's 1/16, but it's just less than 1, and so then we have 1, or this less than 1, so this part becomes what? Negative, over a what? A negative, which makes a positive. And so then I substitute in something between 0 and 1, like what? 0.5, and so this part's going to be what? Up top? A negative over a positive, which makes a negative. And then something more than 1, like 2, and so that becomes what? Positive over a positive, which is a positive. So now I need to analyze my little number line. And so now, do I have any relative minimums? Yes. Where are my relative minimums at? At negative 1, and at what? And at 1. So how do I get the y values of those minimums? I back substituted into our original. So when I substitute in negative 1 right here, I'd have what up top? 2 over 1. So I'd get negative 1 comma 2 and 1 comma 2. So what is the reason behind why I have a relative minimum? Because why? Because f prime changed from what? From negative to positive. Have any relative maxes?
No, because it breaks.
I don't have any relative maxes. My derivative, f prime, changed from positive to negative here, but was it a relative max? No, why not? Because it was a domain issue. It wasn't a critical number, it was a domain issue. It was actually a vertical asymptote there. So I got nothing there. All right, and so when we look at our graph, we have it going from down to up to down to up. However, I have a vertical asymptote going on at 0. All right. We're going to find the extrema of the function 5 minus absolute value x minus 5. So on absolute value functions, I am always going to go back to our algebra and geometry. Okay? And yes, all absolute values look like what?
V.
Flying V's. All right, go Mighty Ducks. And so an absolute value function looks like that. All right, and so if it's just a basic absolute value function, what are our slopes of a basic absolute value function? What is the slope over here? -1. And what's the slope here? 1. And so we don't actually need to do the calculus part if we actually understand the algebra. And so if we actually have like absolute value of 2x, you know what? I'll take a negative absolute value of 2x. All right, and so what's that doing? That one flipped, did it not? And so now my flying V is going that way, right? And so to the left of 0, this would be what? A positive 2 slope. And this slope would be what? -2. And so we have to talk about our transformations as well. And so outside, it does exactly what you think it does. And so outside, this one did what? It went up 5. This negative made it do what? Flipped. And then this -5 actually moves which way? To the right 5. And so I'm actually going to do absolute values, all algebra and geometry in calculus. All right. And so then what do we do here? So this absolute value did what? It moved which way? Right 5 and up 5. And then it did what? Then it flipped. And so when I'm talking about this one, that's my work. This is really my work on this one. All right. And so let's talk about its slopes. All right. So if I were, where's my critical number? Where's my critical number?
5.
I'm critical at x equals 5. All right. I'm critical at x equals 5. Because what happened to my derivative at x equals 5?
It broke.
It doesn't exist. Because why? It's a sharp turn. All right. And so I don't actually go the calculus method. The calculus method is doing a piecewise function with these, and I just don't think it's worth it. I think we can do it without. And so what is my slope? So if I make a sign analysis of this, what is my slope left of 5?
Positive.
It's positive. I want to be specific on this one because they can sometimes ask this question. What is my specific slope left of 5?
Negative. Oh, positive 2x.
It's positive 1.
What?
All right, because my slope here is 1. All right, and then what is my slope to the left or to the right of 5? I'm sorry. It's -1. So now, do I have any relatives? Yes. Where do I have a relative at? I have a relative max at what? 5, 5. All right. And we knew all of that by using our transformations of our functions. All right. And so we have a relative max at 5, 5 because why? There it is. F prime changed from positive to negative. So on 35, we have f of x is equal to x squared over x squared minus 9. And so we're going to figure out when the function is increasing, decreasing, and its relatives. So what do I need to take a derivative of? How do I use it? I need to use the what rule? The quotient rule. So let's do it. How do I notate it? F prime of x. How do I do the quotient rule? Derivative of the what? The top, which is 2x times, and then what? Minus the derivative of the bottom, which is 2x times x squared. All over. All right. And so when we simplify the numerator, what would I end up getting? 2x cubed minus 18x, and then minus 2x cubed. Well, that's convenient. And then what happens? The 2x cubes go bye-bye. And so now what's my f prime? Love it. All right. And so now I'm going to find my critical numbers. And so when I set this equal to 0, what would be my critical numbers? Or number? I just get x equals what? If I set my numerator equal to 0, I get what, Yumil? 0. So my critical number is x equals 0. However, I have two issues. What are my two issues? -3 and 3. Those are not critical numbers. Those are actually what? Domain issues. All right? Because at x equals 3 and x equals -3, what are they again? Okay, they are domain issues, but they're vertical asymptotes. All right? But I still need to use that into our analysis. All right? And so let's do it. So I'm going to do an analysis of -3, 0, and 3. When I'm looking at my derivative, what is my denominator always going to be? Positive every time. All right. However, my numerator is going to change. So if I substitute in something between negative infinity and -3, like a what? -4, then what would I get up top? A positive. And then what would I get from -3 to 0? A positive. How about 0 to 3? A negative and a negative. However, are -3 and 3 anything? No, they are not a critical number at all. And so I can't use this as a relative. What's happening at 0? I have a relative max at 0. So I have a relative max at 0, comma, something. How do I get that something? I substitute back into the original. So what do I get? I get 0 over -9, which is 0. And so why was it a relative max? Because why? F prime changed from positive to negative. All right. Where was my function increasing? I want to keep going there. Where is f increasing though? From nope. From negative infinity to what? -3. And then what? -3 to 0. All right. And f would be decreasing from what? 0 to 3 and 3 to infinity. We can't actually include those vertical asymptotes because, again, they're domain issues. Numbers 32 through 36, even 37, 49. 59 through 70 is going from an F graph to an F prime graph again, because that's going to come up soon.